lose a class with me. So just back on Thursday, we're gonna be putting the metal, pedal to the metal, like metal to you're recording this, aren't you? Okay, dang it. All right, let's go ahead and get started. All right, so today we are going to be doing a lab, and by we, I mean I, sorry. This is the first one. This is where I get to see how well you guys do with a lot of the things. You'll be more involved in the other labs. Also, because I'm doing it on Monday, I just don't have the time to let you guys help me. That sounds really mean. I don't like these. That sounds really mean, but I want you to be able to enjoy the lab and learn about it. And honestly, if I do the lab and you're just recording what I'm doing, and as long as I explain it well, your lab notebook should be pretty straightforward, right? Much better. Okay. So today we're going to be doing the aluminum iodide lab, okay? I always do this lab first. It's one of my faves, okay? This is the lab that I did in front of a TV station in my high school back in the day when we had the special promotion that we were doing where we had to have, where we got to have it would be like WSET, it's WBOC, but it was WSET come to our school. And so they flew in with a helicopter and did all this other kind of stuff. But anyway, I did this lab in a very non-professional way because we didn't have all the equipment, but I had the chemicals, and I asked my teacher, can I? And we had never done a lab before. She goes, yeah, that sounds fine, what else? And so I did this lab, and it's kind of fun, good memories. I also ruined my pants doing this lab because, as you saw earlier with the iodine, for those of you who saw, I just grounded it up and touched it, and it immediately is black, but it immediately just this brown spreads. I've stained the floor here before where I've dropped on the floor, and within seconds it spreads through the wax all the way across the floor. Iodine can stain like nobody's business. Also, large amounts is extremely hazardous. And it has a weird property, which I'm still waiting on. I see it starting it, but you won't be able to see it yet. So I'm going to keep that to myself right now, but you will see it later. I like how Ian's going to go and try to get the full image right now. But anyway, okay. So, am I going to use a full amount for what we're doing? No. But here's what we're going to do today. Okay, for time purposes. I got 10, actually that was a lie, sorry. I got 12 grams of iodine. Iodine is always I2. It's a diatomic element, we'll learn about those shortly. But what that means is it always bonds with another of itself. You never just see I, it's always I2. Like, for instance, oxygen that we breathe is always O2. I don't know if you knew that, but there's two oxygens. Next thing we're going to need to do is some aluminum. Now, aluminum is a really cool powder. I waited so that you guys could see this process as it goes through. Aluminum is a very fine powder, at least the kind that I have back here. A few things that we should know about aluminum. Do not breathe this in. This will coat your lungs like nobody's business and murder you. Okay? It literally says flammable. Oh, it's a flammable solid. I don't know if you knew that either. If you were to throw this up in there and light a match, boom. Case of fire, you have to use an extinguisher or dry sand, okay? Because aluminum's crazy. Flammable solid, keep away from heat, sparks, open flames, avoid contacts with water. Wear protective gloves and eye protection. Wash thoroughly after handling. If swallowed, anyway, just don't do it, okay? So here's aluminum. So what we're gonna do, aluminum is extremely flammable, which is what we're gonna use to our advantage today. And I'm going to pour some out, okay? If you see the dust, of course, don't breathe it. There, you'll be all right. I think so, okay? Now, I don't need as much aluminum as I'm using, but I like to use extra aluminum because it creates more sparks. I didn't figure anyone was going to be upset with that.
As long as I'm not right next to it.
Yeah, so I'm using way more aluminum than I should be using. Just want to make sure that was very clear. There we go. All right, 12 grams of I2 and 12.05 grams of aluminum. When we do this reaction that we're doing today, iodine, we'll talk about this later, but you should remember from last year, iodine is one away from having a full electron set. If you did the Lewis dot structure, right, iodine Looks like that. It's missing one electron. It's octet. You guys remember octet from last year? We're going to cover it again this year, just a little early. Okay? Aluminum, on the other hand, is different. Aluminum only has 3 in its octet. Aluminum loves to get rid of electrons. It doesn't like it. It's easier for it to lose its 3 electrons. Oh, I put A, sorry. It's easier for it to get rid of its 3 electrons than it is to gain 5. So aluminum dumps electrons anytime it can. So we have aluminum that looks like this, and we have iodine that looks like this. Aluminum is going to dump its electrons. One of the aluminums finishes that one, right? And then these other 2 are going to go over towards other iodine. The ratio that we have here at the end is 1 aluminum to 3, because to 3 iodine, because it's going to take 3 iodine to capture each one of these electrons and make everything go through. This will be an ionic compound that is made. There is something at the top of this. We're going to talk more about this later in the next lab, okay? But you're going to see that there is a catalyst. A catalyst in this case is H2O. Anyone know what H2O is?
Oxygen.
Water. Thank you, Indiana, for a solid, real answer. Water is a catalyst. Do you guys remember what a catalyst is from last year? We're going to cover all this again, I promise. But I'm asking to see prior knowledge. Catalyst. Okay. I'll give you an example of a catalyst that might help. Do you know what an enzyme is? It is a protein that does what?
Splits things up.
Not quite.
I don't know.
All right. This always makes me sad. You should know this. Yes?
It can speed up a process without being used or consumed. It
That was a
also
beautiful
lowers
definition.
activation
You either
energy.
just Googled it, or I don't like you. You Googled it. How dare you? Why did you turn it to Jenna? Unbelievable. Okay? Yes, that's true. Okay? An enzyme speeds up a reaction while being consumed. Guess what a catalyst is? An enzyme is a catalyst. A catalyst, by definition, is the same thing. Something that speeds up a reaction is not used. An enzyme is a form of a catalyst. Water is our catalyst. It does nothing more than speed up the process. Water is really good at absorbing electrons. So it's going to grab all the luminous electrons real fast, and then with the iodine, dump it. It's just like a middleman. It's like if you had a bunch of explosive TNT and you had a bunch of matches. Water is just going to be like, bam, and just let it go, okay? That's what happens. There is a heat that's necessary for this reaction to take place. So when we start the reaction, you're going to notice it's going to start off very slow, and that's okay. It will start off slow, okay? So this is the normal way the reaction would work. In order to get from the reactants to the products, there has to be a certain amount of activation energy. So think about like lighting a match or heat applied or something like that. Water, it's not that this doesn't still exist, but water makes the reaction more like this. It's like it burrows a tunnel through the mountain to make it easier. And by the way, when the reaction gets down to here, this releases heat. So heat's being released. So if you can imagine, once a reaction is started and gets up here and it drops and the heat's released, that heat can go back to raise up the rest of it. But because water is going to speed this process up, once the heat's released, very little is going to have to be done, and the water's just going to speed the reaction up. It's just going to keep getting worse and worse and worse and worse. I mean, or better and better and better and better, depending on what you like with the reaction. Any questions on this? I know you're all just staring at me, taking good notes. Okay, that's the reaction. Well, recording. Here's the reaction. Water's going to be our catalyst. It's going to speed things up. We're using way too much aluminum for fun, and very little iodine, again, for what we should be doing. And we're going to mix this up. I am not going to mix the reaction in this room. Why?
Toxic gas.
Because it would blow us up.
Why? Well, it's not going to blow us up. It'll smoke us out. But why? Think about it. Why wouldn't I mix it in the room? I just said that water is a catalyst, right? Okay, so if I'm not adding water to it, I mean, that's a pretty big, steep thing, right? So we're not going to worry about anything, right? I mean, ideally, yeah? What's the problem? No? That's a great thing to
Water
think
in
about,
the
but
air.
no, it's not for water safety.
Sniffing it.
No, well, that too, but no, not really.
Using up oxygen?
No?
Water in the air?
Is there moisture in the air? If I mix this in here, the moisture in the air will start this reaction. It'll take a little longer than normal, but it will still work. In fact, it's pretty humid outside, so I actually have a feeling I might not even need to start this reaction today. It might just work with the moisture in the air. We've done this on colder days where I actually have to like go crazy with adding stuff, but I don't think we're gonna need that. Any questions, comments, concerns? Are y'all ready? All right. So what we're gonna do is the following thing. I need a few volunteers to assist me. Who wants to hold water? Colin, congratulations. It's safe. You're not gonna hurt yourself.
You don't know Colin very well, man.
You're right. I don't know what I was thinking.
You keep him glass.
Now, Colin got really excited, but he's gonna be sad when I say this. Who wants to start the reaction? Piper, congratulations. That's just a pipette, not piper, but that is a pipette. That's literally what it's called. It's called a transfer pipette. I gave the pipette to Piper. Piper pipetted. No, I'm just joking. Okay, it's like trying to come up with something really good there. Okay. Who wants to carry out the aluminum? Yanina, perfect. I need you to put on a pair of gloves. I'm assuming, can I see your hands? Just open your hands like this. Yeah, small. There's some small gloves right there on my desk. It has the S by it. It's the bottom of the blue one. Okay? Who wants to carry out the iodine? Susan, put on some gloves. Let me see your hands. Yeah, about the same, small. See, it's the blue ones right there. Susan's got it. Yanina. Okay, now, I don't know if enough time has passed, but I can see it already. It's faint. It is very faint, but you can see it more so from the top, but it's not my gloves that you're seeing. Do you notice that it's purple at the top? Slightly, do you guys see that? If I left it out or mixed it around a little bit, I can actually see the gas is floating right on top of the iodine. Iodine has this weird property where it doesn't it can turn into a liquid, but it doesn't. It sublimates. It goes right from a solid to a gas, which is one of the reasons why iodine is so scary, is because it literally has put purple iodine. It's already like seeping through this already, and it will mess it up. It's one of the reasons why we use glass to hold iodine, because if you use plastic, it'll leach through the plastic and literally come out and then murder you slowly.
No,
Okay?
that sounds fun.
Make sense? I just want you to see the purple. If you guys want to take a picture, I mean, we can when we go out there. Susan will be holding it, right? Just don't take anything off of this when you go through. Okay? And then I need a strong, manly man. We don't have any of those in here. So I'll have to pick on a weakly man. That was a horrible joke. I'm so sorry, Ian. Josiah, by the way, a lady can do it too. It's just whatever it is. There's a sandbag back there that weighs about 25 pounds. If one of you would be happy, you don't have to grab it right now, but if one of you would grab that when we go out. There is a hole, so just make sure you don't get sand all over you. Because last year I had a kid that decided to punch a hole in the bottom of it.
Who is that?
I don't even want to talk about it. All right, so anyway. Make sense? Okay, let's go.
So I have to grab it now. Oh, I don't want that.
Susan? Okay, Yanina, there is no cover to this. So do not sniff it, do not breathe it, do not try to lick it. By the way, yep, see, isn't that cool? Iodine, yep. So like I said, just keep it on your gloves and nowhere else. Little bits of it will seep through and start staining.
I have no clue where the hole is.
Oh, good.
Perfect.
Okay.
Look at
Okay.
that.
We've got water, pipette. We've got that, and we have sand. All right, let's go. And you've got my radio, and I've got my keys. We're going down closer to the baseball field. I love how I'm being cinematography.
Ian, you're too far back. You can't hear him.
The most important thing you should know. Oh, Ian, you missed out the most important part. Sorry, buddy. You see that dead spot with no grass? That looks good to me.
Which one?
The one straight ahead. You need to take a right
There's
a little bit.
two straight ahead. There's actually, three, kind of. There's one right here.
Alright, this looks good. Nothing here to hurt. No, it's not really. Okay, you got that? Oh, can you turn it on? Oh, it is on. Never mind. We're good. Okay, everyone take a few steps back. This isn't going to like be explosive or anything like that, so I don't want you to like worry. I just want to make sure I do this the right way. Okay, Piper, can you go squeeze that tip, go to where Colin is and grab some of that water from him? Okay, when we start this, you're going to need to put like 2 drops in. And we might not even need to. It's pretty humid out here. Ooh, purple. You guys can take a picture of that later. Ooh, weird. I definitely put a lot more aluminum than I should have.
So is there like any cure for like sniffing it or no? No, let's not think about it.
Alright. I definitely put more aluminum than I should have. Here's the purple, by the way. I'll just leave this over here so you guys can see that. Piper, go ahead and put like 1 drop in the center and let's see what happens. Perfect. Alright, now we wait. This could take anywhere from 30 seconds. It could take up to 3 minutes. If it takes longer than 3 minutes, I'll go get some more iodine and add some to the mixture. We just have a lot of aluminum, which is great, as long as the iodine takes off. And now we sit here and be bored and be sad.
So how you doing, Ian?
I don't know. It's supposed to spark. Are you taking pictures or a video? Wait, I'll do pictures. I was just asking. You don't have to. I'm taking pictures. No. I think that's my phone. Jenna, you gotta smile. Yeah. Sorry, my phone's very clear.
All right, it is starting. If you guys want to with your cameras, you can pull up. You can look in there. Just don't breathe the smoke. The smoke will stain your clothing and ruin your life. But there is some purple smoke. It's very faint that's building up right in the center. Piper, you can add another drop to the side of it. Oh, well, that was a lot more than what I was looking for, but that's okay. Let's see what it does.
I didn't see anything.
Do you see that purple?
No.
It's very faint. Just keep looking. Don't worry. You'll see it later. Don't worry.
Kaboom.
But the smoke itself will stain your clothing. So if it comes your way, just move a different direction. Please don't scream. Every year people are like, ah!
Shopping spree.
Shut.
I think I see it. Yeah, I see it. Oh, I see your shoes, Michelle. Cool.
Oh, that's cool. Thanks. Maybe I'll put them in the smoke and I'll have purple shoes.
Oh. Wait, it stains it purple?
It'll be
Actually, it stains it like a weird, like orange, like yellow color.
Does anybody like orange or like no?
I'm getting stuff all over me. I put too much. It looks like it's gonna work. It's just I'm waiting for it to like kick in. The activation energy. Oh, hold on.
I think you might need to move, Ian.
Ian's like, let me breathe it in. All right, do you guys see it now? Now you should really start to see some purple now coming off of it.
I can barely see the gray. Oh my gosh, you're calling me.
Why is it coming towards me?
Because it loves you.
I don't like it.
Oh, it's a heart. Is it a heart? Oh my gosh. Oh, okay.
All right, now, Ian, you're good right now, but watch that smoke as it comes over. You can
Oh, no,
always
it's
move to
going
the
in.
side.
Oh,
to
it's like
still get
getting
the same
like
shot.
really purple.
Just get to your shirt.
Oh wow.
My phone's not picking up.
Oh, whoa, Ian.
It's just coming to you. Oh, it's so cute. Look at it go. Oh. It's so cute. That one's kind of. Oh, look at. Oh, Piper likes
Ian,
you.
Ian.
It's purple.
Oh, I see the yellow.
Oh, Ian, you got like the sunlight behind shot. Look at that.
Oh wow.
That's pretty cool.
It's so pretty.
Oh.
See the nice fire?
It's coming for Ian.
Do you guys see what it did to the ground too? Isn't that cool?
Oh, it's like perfect.
All right. This looks like we're doing a great job here. So let me ask a question real quick. If I want to put this out, the best way to put it out is with water, right?
No.
Water would make it even worse.
But wait, don't you think water would help it, like, to go out? I thought most of you wrote on your test that water would be a great idea to put something out. I'll do this.
Ah, Piper, you might
Darn, I wanted this too.
Oh, look how pretty it is. Look at the grass all dying nearby. So if I add water to it, what do you think will happen?
It'll blow up. Do it.
It's not going to blow up,
Oh,
but
man.
it will spark and get real hot,
Oh,
and then okay, it's not going to be like that.
Oh wow.
Yeah. So what do? Yes, technically I stopped the reaction. I mean, it's still going, and technically if there was more, it would have just flared up, right? But I just already used a lot of it. What's the best way to put this out? Sand. Okay, because sand will, actually put it out. Some of you guys don't even care about good science.
No, we just want to
Did you guys want to get a picture of the ground before I cover it?
Like change the color.
Ladies, if you would, actually, can you move to the side? So you're blocking your shadows are. Keep going, keep going, keep going. There you go. Now you can get your photos. Yanina!
I already did.
Unbelievable. Taking a picture of a cloud.
It's like that.
You all good? You got what you need? Doesn't this just make you want to play in a sandbox?
You're playing that. What?
Oh. All right, while we're outside enjoying the beautiful air, any questions, comments, concerns that you have about what we have?
There's no purpose in it. Just like.
Not quite. There's the purple, in case you wanted to see the purple. See it?
Wow.
And yet again, someone stepped in the light.
Oh, that's you. Shame on you. Oh, sorry.
Cool. Let's go back inside. Let's talk about the final steps, and we'll go from there.
It'd be fun if we did that on a larger scale.
Oh, don't worry. We might at some point.
Wait, really?
Yeah, if I'm being honest with you guys, I was limited on the amount of iodine that I had today, so I just did a small demo, which actually is about what I do every year. But if you guys can hang with everything, when I get an order of iodine in, we can do a larger version.
Like 30.
Okay. One thing I will say, did anyone reference, and probably didn't notice it, but did you guys notice what it looked like? Yeah, I know it looked like a cloud, but like think about like where you may have seen a cloud like that.
The
sunset?
or sunrise?
No.
A cloud? Like
Think
that?
military.
That one scene?
Oh, smoke bomb.
Yeah, when they do like when they paint a target. Some of that's going to react. When they paint a target, so like if there's an airstrike or something like that, I'm not saying they use exactly that formula, but they have like a grenade thing that they launch. It's not a grenade, it just releases like a purple or like a pink smoke so that an airplane can see where to strike and shoots out like to bombard an area in the military. Okay.
Yeah, it kind of looks like the balloons from up.
When I did this for WBOC back in the day, the guy said it reminded me back of my days in Nam, and he started going on the Nam story. It's kind of fun. like Vietnam. Okay, moving on. Let's go.
Let's just put it all on you and
There goes my love.
The limiting thing that we had there was the iodine. If we did 30 grams of iodine,
That'd be fun.
that would be nice. Doing 50 would be great. Maybe later this year we'll do 50. That would be fun. Okay, let's go. I'm gonna leave this in there.
What's the point of that?
I'm serious.
I feel like you should like upload this to a Google Drive or something. Because it might be too big for.
I'm gonna put we should do this thing next.
No, wait, no, we just post it on Google Classroom. That's the easiest thing.
I don't know what I'm gonna do.
It's like,
Someone wants to leave around the picture. Somebody will be. We were holding the water, so.
I wanted to be the one to dump it on. That looked so
For
fun.
safety reasons, I didn't feel like that was a good idea.
But it looked fun.
Why was it wrong? If Colin gets hurt, I mean, like.
To be fair, I'm used to doing more than that, so maybe my reaction was unfounded, but ew, look at the iodine that was left in that. I just added water to it.
How would you describe it? It kind of looks like beer from here.
It looks like Jeff.
Ooh, drink it. Let's see what happens.
You.
It did.
You should drink it, Ian.
What?
You left us outside.
What outside?
They shut the door and didn't look back. Some other person was.
Wow. All right. I know that today's lab was more so the demo, but I just want to show you how two chemicals can make a reaction. Would anyone call that a fast reaction?
Yes.
What it took off, right? But like overall, like that's almost like a timer, isn't it? Like you talk about sometimes like people saying delayed fuses. That's a phenomenal delayed fuse. As long as you have the mixture right, okay? You could set something like that. I'm just throwing this out there. I'm not saying you should do it. Please don't do it. You could set something like that, add the water to it, and walk away. Well, that's what I'm saying. And like you could do like, I'm not advocating this, of course, and some of you are still recording this, and that's fine. I need to clarify for legal reasons, I'm not advocating something like this. Thank you, Emily, for the clarification.
You can pause the video too.
But for clarification, like if you wanted to set off like fireworks, because you love Lord of the Rings and fireworks are so great, you could literally put this underneath of the fireworks and let it go off, and when the fire burns and starts going, it'll light the fuse, which then will set off the fireworks 5 minutes away, and you're far away, so no, it can't be you because I wasn't there. You have an alibi because you find some other person and you talk to them and say, hey, well, do you have the time? So that they say what time it is. So you're like, oh, so it's 5:45, so it's burned into their mind. They're like, no, Mr. Hill was with me at 5:45. There's no way he could have gone off. All right.
So he's teaching us how to blow things
I
up.
did not teach you any of
Yes,
those
and
things.
get away with it.
Okay, but this is just a simple reaction. It's just two different compounds, and they made something like it's a new compound, aluminum iodide. Iodine. So keyword: aluminum plus iodine. Iodine. INE makes aluminum iodide. ID. And did you ask the person who ate iodine what happened to them?
They die.
Iodine.
Oh, I guess I died, right?
I'm sorry, I know. And you guys have that recorded too, so you get to hear that again, of all things. Okay? Activation energy, remember the water just sped this up. If I had just mixed that sample and left it out there, I don't know how long it would depend on humidity. It could honestly have just sat out there and 3 hours later then gone off. Okay? Kind of cool, right? So water does the activation energy, lower it to get the product, which we have over here. I don't think there's anything else I'm really missing. Now what I will say is this, when you're doing your lab write-up, you are more than welcome to go online and look up the aluminum iodide reaction to find graphics other than what you have, maybe pictures, or if there's a better explanation that you find, just make sure that it's this formula. There are other reactions that do similar things that are not this formula, okay? So you just do aluminum iodide, make sure it's this formula to go forward. I do not mind if you supplement material, but just don't say things like this. Mr. Hill got the stuff and he mixed it in class and then walked out, because that's what you read online. That's not what I did. When did I mix it? Okay. Cool. Your lab notebook is going to be due in 3 weeks from today.
Uh-oh.
Okay? It'll be after fall break. So you have fall break. Okay, listen, can I just say this? Do not waste your fall break working on this stupid lab notebook. Get it done prior so you can enjoy your fall break. Because if you don't, you're going to be up on Sunday night going, and losing your mind. Okay? I highly recommend you do it as soon as possible. You don't have to get it done tomorrow, but I would get it done soon while it's fresh in your
I'll
mind.
get it
And while you got
done.
all these great details.
2 weeks and 6 days.
I was just smiling for the camera. Yes, sir.
Could you post maybe somebody else's example of a lab in
Didn't I already
your
do that?
classroom?
Didn't I already give you? No, I showed you Gabriella's. That's what I did, right? Yeah, I'll let me reach out to Gabriella, make sure she's okay with it. Or if not, I'll find another student that's fine with me pilfering those and sending to you. It will not be of this lab though. Okay? I will not do that. Okay, because that's not fair to others that did the work and then you just copy and it's fine. Cool. Both of those were there. That's good. Okay, that's it. We're good. Man, I was rushing because I was afraid we were going to have enough time. We had it all done. I'm just waiting for you all to turn off the video so I can say other horrible things.
Ian will never turn off his video for this entire class.
That's fine. The lab notebook, remember the rubric is up there. So make sure you have the equation and talk about what it was. What was the objective of this lab?
To blow things up.
No.
Understand how catalysts work.
I would probably, that's pretty decent, to understand how catalysts work, to, what would you say? To see the reaction between aluminum and iodine. I think that's fine too. Okay? Or both of those would be a great objective. We did the experiment, the procedure. You guys didn't do very much. You guys basically talk about what I did the whole time. You could talk about how Ian kept getting in the way, or how the girls kept getting in front of the shadows and causing stuff like that. You could do all that, but you don't have to do anything crazy like that. I would mention who was doing what. Susan had the iodine, Yanina had the aluminum. What happened to Susan's gloves?
They rusted.
They
Well, I don't know if rusted.
they stained. So talk about the procedure, what happened. Was there any data for this graph? Like, is there a chart we can make from today's?
I don't think so.
No, I mean, besides mentioning the amounts, what you do in the equations, I don't really think you need to mention anything like that. Were there mistakes?
Yeah.
Yes. Name one. Yeah, Piper added 1 drop and then added 17 million drops the second time. But it's okay, the reaction still worked. The difference is if she had done 1 drop again, it probably would have happened a lot faster. Because even though the water speeds it up, which it did, by the way, it also absorbs more heat, right? So the water was absorbing the heat first. Once the water had basically boiled off, which you didn't see it just evaporated off, that's when the purple smoke started happening because the temperature went over 212. So adding more water isn't necessarily bad, it's just you have to wait for the water to absorb all the heat before the reaction takes off. That's all. So that's cool. Listen, it's not the first time it's happened and it worked great, so I'm not worried about that. It took a while to give your videos, so you can talk about how long it took from initial ad or even the second ad till it took off. Let's see. Talk about that. Professionalism is just your doing. Spelling is just your normal thing, so that's not a problem. Citations, if you use someone else's video, make sure you say this was Yanina's video, this was Emily's video, or I use XXXXX, that's fine. If you put it up on a drive. And then materials, what did I use? Iodine? Aluminum? What?
2 container things.
2 beakers. And then the containers that you held, they're called weigh boats. And then I used, what did I do with iodine? Did I just put it straight in?
Yes.
No. Prior. You guys didn't have your cameras at this point. I measured it and I did what with it? I grind it with a mortar and pestle, right? It's like what you see on the pharmacies. I grind it to make it really fine so it's smaller pieces that can swap stuff quicker. Gloves was a huge one. Lab coat for me. I didn't make you guys wear lab coats. Should I? Probably have. Yes. But to be fair, the only thing that was going to be was on that, so as long as you weren't like rubbing it on your body, you should have been fine, right? And you had gloves, which is the most important part, and you saw where it protected you. What happens with the smoke? Do you want to be near it? Do you want to get tie-dyed?
Yes. That'd be fun.
It would be fun, but no. Ian, what's your question?
2. 1. Where did the activation energy come from?
The electrons swapping, whenever electrons move, we register heat as part of the byproduct. So it's the swapping of electrons. Water just helps speed the process. The more electrons that move faster, the higher the heat rises. So the heat came from the electrons moving and water just sped that up after it heated up, right? So water sped it, and then the water took the heat, and then once water stopped, then the heat went to do the reaction the rest of the way.
And then, what kind of adverse reactions could happen to a human who breathes in the smoke?
You
From either
die.
of those, suffocation, death, major issues with your lungs, coughing, I guess in large amounts, cardiac arrest, possibly, because I mean it's displacing oxygen. And iodine, just as itself, we do need iodine to live, but not that amount, and not from your lungs. So it messes up your lungs pretty bad. Aluminum, if aluminum coats your lungs, it like sticks to it, and it can cause major issues, including like cancer and stuff like that down the line. Anything else? Guys, what a fun way to spend our day. I'll see you on Thursday.
It's like the 10th time you told us how to die.
Oh, don't worry, there are plenty more coming.
I know.
And a lot of them are more fun. All right, now that I've got everything done, phones go back into your homeroom places. Do not care about, Mr. Wilson, we could have them today. We'll put them back. By the way, Mrs. Alley, just as a throw out, Mrs. Alley is really not on board with me letting you use your phones, but I go to bat and say, but my students will take care of everything. So you make me look bad, but I make your grades look bad. Okay? You understand? So I don't want you going around telling people that I said that you can use your phones outside of class. What a nice picture, guy. Goodbye.
Oh, I gotta put my name on this. Colin, come here.
What? What?
I can't tell if he's taking still photos of me or he's just waiting for me to say something. Lydia, it's about dang time you showed up. You haven't taken your test yet. I couldn't even pass out the test today. It's all graded. Oh, your tests are all graded. They're all graded. Yep.
Stop it.
Oh yeah, Mr. Hill.
All of them, except for Lydia's. If you had yearbooks, you could come back.